Okay, quick video on how to build some real heat engines, and the simplest heat engine you can build is a steam turbine. Many heat engines, many heat engines, let's get this going here, use a gas of some type, and of course steam is a very common gas to use because it's just water, vaporized water. Okay. So what we have here is we have some water, and there's a fire built underneath this box right here. I don't know how to draw flames, so you're going to get these little shapes I saw in the gas commercial. Okay, and that makes some pretty high pressure steam. The steam is forced to go through a turbine and spins the blades of the turbine. And after the steam spins the turbine blades, it's at a lower pressure, so it falls down here, and we need to collect it into another container, which is the condenser, and that allows the steam to condense back into water, whereupon we pump it back into oh boy, I better get this right. We'll have an MC Escher situation on our hands. So this is a pump, and we pump the water back into the vessel where it is heated and turned into steam. So we have high pressure steam, we have low pressure steam, and then it condenses back into water where it can be pumped back up and turned back into steam. So where is the hot reservoir on this engine? Well, the hot reservoir is this constantly boiling source of steam. Where is the cold reservoir? Well, the cold reservoir is over here where the steam cools back down and condenses back into water. And the flow of heat, well, the heat is added to the steam here, and then some work is taken, but this still is hot and has to be cooled back down. So the waste heat goes into the condenser, and the heat from the hot reservoir is generated by this fire, and our work comes out when this turbine spins. If you're really smart, you take this turbine and you hook it up to this pump. Now, if the steam is of high enough pressure, there'll be more than enough energy to run this pump, and the rest of the energy you can take out and have it generate electricity or something like that. This, however, is not the very first steam engine that was ever invented. The very first steam engine that was invented was a piston-type steam engine, I believe. Well, the very first one was probably Hero's engine, but that's neither here nor there. So how about just a regular old steam engine? Now, this steam engine is based on a cylinder and piston. And for those who don't know what a piston is, imagine you had a cylindrical shape, and I'm just going to draw it in, two-dimensional here. And instead of closing the bottom with more of the same material that made the cylinder, you have a false bottom. It fits very tightly against the walls here, but it doesn't allow gas to escape. And then if we were to add pressure to the gas that's in this area here, it would push this piston down. And this stick on the end of the piston could be connected to some sort of wheel that would spin around, and usually you do that with like this. And if we could put steam in and out of this cylinder, we could push the piston down and suck it back up and push it down and suck it back up. And that's what we do for a steam engine. And in fact, this diagram, if you turn it on its side, that's what's driving the wheels of a train, a locomotive, a steam locomotive. So here's how it works. We're going to need this piston that I've got drawn here, and I'm going to draw it in a little more simplistic way. And what we're going to do is we're going to have a pair of valves. And this side is just going to vent to the air, but this side is going to be hooked up to a boiler. Tedious fire drawing again. So we're going to make some steam, and what's going to happen is we start with the piston at the top, we open this valve and high pressure steam rushes in and pushes the piston down. That pushes the stick down and makes the wheel spin a little bit. Then we close this valve and we open this valve. Now this wheel that's down here is a flywheel. In other words, it has some mass to it, and it continues to spin and it will push the piston back up. So first the piston went down, and then with this valve open, the flywheel will find it easy to push the piston back up. Then we close this valve, open this valve, and the high pressure steam pushes the piston back down. So the piston goes up and down, up and down, up and down repeatedly. That is the simplest way to build a steam engine. It's a bit wasteful. In other words, our steam gets used in the cylinder and then just vented to the air. So on early steam locomotives, you had to constantly refill the boiler with water. And that's why stations were a certain distance apart, and you would come to these stations and stop for a second, and there would be a giant water tank, and they'd swing over and top off the boiler, and then you'd have to seal up the boiler and get it back up to pressure. And so people who were on the train usually had 15 minutes to half an hour to walk around town and see the sights. They call that a whistle stop, right? Because they would blow the whistle when it was time to get back on the train and go. All right, how about an internal combustion engine? Otherwise known as an ICE to those of us who have electric cars, because, you know, as to different than an electric motor. The internal combustion engine goes through a very similar cycle, only we need 4 diagrams to show you what's going to happen here. So I'm going to draw 1, 2, 3, and 4. And what we're going to do here is we're going to have a couple of valves, one on each side. The piston is going to start at the top, and over here is going to be a mixture of gasoline and air. And so first thing you do is you open this valve, and the piston is pulled down by the flywheel, and it draws in some gas and air. Then both valves are closed, and the piston is pushed back up to compress the gas and air, and then a spark goes off to ignite the mixture. Both valves are still closed, and the igniting mixture pushes the piston down violently, and then we open up this valve, leave this one closed, and the motion of the flywheel pushes the piston back up and expels the exhaust. So this is a 4-cycle engine. It takes 4 steps. And the 4 steps are called intake, where we're bringing in the gas and air mixture, compression, where we're compressing the gas and air mixture to make it more, explosive. Then the power stroke, that's where the gas and air mixture is burning and pushing the piston down under a great deal of force. And then, of course, this is the exhaust stroke, getting the old gas and air mixture out of there to move it along. So really, in a car, only 1/4 of the time is each cylinder making energy, doing work. The rest of the time it's housekeeping, bringing new fuel and air in, pushing out burnt fuel and air, and doing that compression stroke, which actually takes a little bit of work out of your things. That's why engines generally come in 4 intervals of 4 cylinders, because that way there's one cylinder always at any given time doing the power stroke and providing the power for the compression, intake, and exhaust of the others. There's no law that says it has to be so. You could have a 2-cylinder engine. You're just going to need a bigger flywheel to store some energy to do compression when there isn't another cylinder doing the power stroke. Okay, but there are 4 steps of it, so it's called a 4-stroke engine. Now, some of you, maybe those of you who ride motorcycles, might know that there are 2-stroke engines, and they work in a slightly less efficient way, in the sense that the intake and exhaust cycles are the same. So new fuel and air is coming in when the old fuel and air is going out, and they use a special shaped exhaust to act as a buffer for this thing. And then the compression let's see, what is it? The compression and yeah, I think all three of these are the same. Stroke, and then the power stroke is the other stroke. You can get on the internet. There are some animations out there that show you how it works. But in this case, the piston needs to go down and up twice for one cycle. In a two-stroke engine, it only goes down and up once. But then again, unburned fuel is being sent right out the exhaust because there is a moment when both of these valves are open. Okay, so that's how you would actually build a heat engine, usually with some sort of piston and cylinder arrangement, definitely some sort of heat source. Oh, I guess we could ask ourselves, where's the hot reservoir here? This is the hot reservoir. Where's the cold reservoir? It's the atmosphere. Here, the hot reservoir is the burning fuel. So this phase. And what's the cold reservoir? Well, the cold reservoir is the exhaust. It goes out into the atmosphere. In your car, there's additional cooling that needs to take place because at the temperatures that the gasoline burns and the friction of this piston with the metal walls, you could melt the metal, and then the piston would stick to the cylinder and no longer go up and down. So we have to, not only do we have to slap oil in there to lubricate the sides of the piston, but we also have to have passages that have water passing through them to cool off the walls of the cylinder. And that water needs to be cooled off as well, and it's cooled off in your radiator, and everything, all of it is dumped into the atmosphere of the Earth. So yes, cars pollute with chemical pollutants, but they also pollute with heat. They heat up the atmosphere of the Earth. And the question is, how much? Well, that's for us to decide. How convenient is it to have an internal combustion engine? And don't get me on a soapbox, but I will sometime. All right, those are the videos I wanted to make for you. Probably not my best work, but that's what I want you to know about from thermodynamics. We'll have a review video next, and off we go.